For those who haven't met me before, I'm Barry from Barry's Tutoring. Please feel free to check out my Facebook page. Just search Barry's Tutoring. I do one-on-one tuition for Section 3 of the GAMSAT, as well as maths and science in general. So today, I was thinking to go through ternary graphs, which are graphs which have three axes, and it's a triangular shape. There's a similar question that is in test 3, one of the more recent papers that have been, practice papers that have been released by ASAP. This is a question which I've kind of written in a similar manner to that particular question. Okay, so I'll just read the question. Pure gold is slightly reddish, yellow in color, but colored gold in various other colors can be produced. Alloys with silver and copper in various proportions can produce white, yellow, green, and red golds. These are typically malleable alloys. Pure gold, essentially 100%, is 24 karat by definition, so all colored golds are less than this, with the common being 18 karat, 14 karat, and 10 karat. Sorry, 10 karat and 9 karat. A ternary diagram showing the different colors of Ag, Au, Cu, or silver, gold, and copper alloys are shown below. Points 1, 2, and 3 represent different metal alloys. So here we've got a typical ternary diagram. What you have on the three different axes are weight percentages of the three different metals that make up this alloy. It's always good to look at your axes and what the units are. And you can also see that there are several, regions that are marked by these little boundaries. Okay, so for example, what this is saying is that if the gold has this certain proportion of copper, silver, and gold, it's going to be of a whitish color if it falls within that region. Okay, so let's go to the question. Question 14, the metal alloy represented by point 1 contains. The metal alloy represented by point 1 contains. So let's go to point 1. And notice how they haven't told us how to read off the graph. And this is probably where most people would get a little bit freaked out by a question like this. Okay, they have not told us how to read off this graph. The GAMSAT is very much about problem solving. And so really what I'm going to show you here is how you can kind of stumble across the answer, okay, just using a bit of trial and error. For point 1, let's say we wanted to try to read off the graph to get a value for the weight percent of copper. So we want to read off the bottom axis. One thing that you do need to know for these types of graphs, though, is that to read off a point, you need to follow the grid lines that are provided. Okay, you can see that there are some fainter lines. I'm kind of going across this way, that way, as well as horizontally. Those lines are parallel with one of the sides of this triangular graph, essentially. So if we try to read off the graph for point 1, a value for the weight percent of copper, there's only two different lines that we can follow. We can follow the one that kind of goes diagonally up and to the right, or the one that goes diagonally down. Okay, because if we followed it any other way, let's say this way or that way, it would never hit that copper curve, the copper axis, I should say. Okay, so what do we get? If we read off these two different directions, you get a value that looks like it's about, 15% perhaps, estimating. And then if you read off from here, let's say that was correct, that's about 55%. So let's look at the options. If you look at the options for copper, okay, which are these values down here, the only one that really makes sense is 17%. Oh, well, that's given it away, hasn't it? See, that's the only one that makes sense. So that's got to be, it's got to be C. That was easy. It's got to be C. Another thing that we have learned is how to read off the copper axis. So we now know that we need to, from now on, read off in this direction for copper. Okay. So for completeness sake, let's try to read off the graph for the other values and see if it makes sense with our answer. Let's try to read off the AU axis. Now, technically speaking, I'll use a different color here. Technically speaking, if we wanted to read off the AU graph, there are two ways we can go from one. And disregarding what we've just figured out, we could go along the same line like this, and we could go horizontally. Now, if you go horizontally, you can see that, and I'm not being very accurate, but you can see that it's about 40% off the AU or the gold axis. But if you read up diagonally like that, you get a value that's more like 85%. And if you look at the values for AU, there's no 85%, but there is something that's close to 40%. I'd say 37 is probably the best. So now we know to read off the gold axis, we need to go in that direction, okay? And so on and so forth. Okay, and then it should be pretty clear that silver, you can only read off in this way, this direction, or you can read it off again horizontally, and you get values of about 40 something. I'm not being very precise, that's about 45, let's say. That it's a bit more than 60. Let's just say 62, just to put something there. And again, if you look at the values for silver, the one that makes most sense is probably the one at the top, the roughly 45% region. Okay, so this is how we've essentially stumbled across our answer, which is C. And I guess now that we've learned this and we can apply this to situations in future, whenever you're reading off one of the axes, whatever direction that you read it off, you can't use that direction again for another axis. So you can see that reading off the graph, they are all different directions. Okay, so the green line, the red line, and the blue line, they're all different directions to each other. Okay, so that's how we've got 14. And this has essentially set us up for the rest of the questions. So let's have a look at question 15. Piece of gold jewelry classified as 18 karat can be. Okay, so 18 karat, we need to somehow find a way to relate the carats to this graph. Okay, we've only got weight percentage of the different metals. But if you go back to the information that's being provided, particularly in the second paragraph, it defines 18 karat as being 75% weight in gold. Okay, so it's talking about the gold content. So something that is 18 carats is 75% gold. Okay, now this is good because we now know how to read off this graph. Just choose a different color. And it's going to be, well, for this particular question, when it's talking about 18 karat gold, it's going to be relevant, or the gold axis is going to be relevant to this particular question. So let's go to 75%. So reading off this axis, 75% is going to be about here. Okay, that's about 75%. And if you look at the lines that we've drawn previously, the red line represents how we would read off the gold axis. So 75% would represent any value around, or any value that kind of fits along that line that goes horizontally. Okay? And you can see that this line that we've drawn, which represents 75% gold, okay, or 18 carats, this line goes through 3 different regions. It goes through green, yellow, it goes through yellow, and as well as goes through reddish. Okay, it goes through the reddish region. So let's look for that answer. Green, yellow, yellow, and reddish. Okay, happens to be A in this case. Green, yellow, yellow, or reddish. Okay. Okay, question 16. An alloy Y contains 65% copper, and alloy Z contains 15% copper. Which one of the following is true? Let's go and mark those values off on the graph. 65% copper for Y, 15% copper for Z. Let's get rid of this for now. Let's try a different color. Okay, I've got the memory of a goldfish, so I think it was, let's just double check, 65% copper for Y. So copper is on this axis, the bottom. 65% is going to be around, yeah, 65%. That's going to be a Y. And 15% is going to be about, yeah, it's going to be a Z. And we know from the very first question that to read off the copper axes, we need to go reading left to right, diagonally up and to the right. Okay, so the lines that we can draw from the 15% mark. Okay, so that line is representing 15% copper, and this line over here is roughly representing 65% copper, or the alloys Y and Z. Okay, let's just go back to the options. So which one of the following is true? It says Y must be reddish and Z must be white. Let's have a look. Y must be reddish and Z must be white. Now, you can see that Y, some parts of the line do cross reddish, and also the majority of, or actually some of the line for Z does go in the white region, but they don't have to be white or reddish, okay? Because in actual fact, Y could also be copper, copper red, I should say, okay, which is in this region over here, for Y. And for Z, which is 15%, you can see that that line crosses whitish as well as pale greenish yellow, as well as yellowish yellow and reddish. Okay, so it crosses through quite a few. So it's definitely not A. And if you notice how it's been written, it says A must be and Z must be. You know, it's very restrictive. So B is probably not right as well. It says it must be and Z must be, because we can see just from the diagram that Y and Z could be a range of different colors. It's probably not B. We'll look at C and D. So what it says, both Y and Z could be white. Let's have a look. Is that true? Okay, now if you look at it, we can see that Z definitely could be white. Okay, Z is the line that represents 15%. But Y, which is the 65% line, only goes through reddish and copper red. So that statement is not correct. It has to be D. Both Y and Z could be reddish. Let's go and just double check. So reddish is this region here. A horrible color to choose. But anyway, you can see that that region, the 15% copper line, as well as the 65% copper line, goes through that region of reddish. So that is a possible color that they both could be. So that makes sense. Okay, and we're down to our final question, 17. Which of the following is the closest to the maximum proportion of silver? Okay, the maximum proportion of silver, that's a horrible color. Maximum proportion of silver, so we're talking about Ag, that could form an alloy with copper red color. Okay, what is the maximum proportion of silver that could form an alloy of copper red color? Okay, let's go have a look at copper red color. Get rid of some of these lines. It's starting to get a bit messy. Okay, so you can see that the copper red region is here. Okay, that's copper red. And we want to know what is the maximum, double check, maximum that Ag could be. Silver. And the maximum proportion of silver that could form an alloy with that color. So if you look at silver, okay, that axis is for the weight percent of silver. To read off that axis, you need to go down and right, okay? And essentially what we need to look at is the range of values. We want to look at the maximum. So the range of values, which could give us copper red. Now, looking at this direction, hopefully you can see that the boundary for copper red starts about here, which is parallel to the Ag. Okay, so this represents 0% silver. So 0% silver, if you read off the curve, it will go into the region which is the copper red. Okay, so what that means is if you had 0% silver, you can produce an alloy that is copper red. Okay. Now, if you keep on going, so essentially, if you just keep on going this way, you can kind of draw more lines if you like. So if you draw more lines going diagonally down, you can see that all of these lines would go into this region. Okay, these diagonal lines. So you could produce copper red. It's only until it gets to this point over here that you can't produce it anymore. About there. Okay, so hopefully you can see that if I went any further higher, with the weight percentage of silver, we're no longer going to cross into the region of copper red. So this value, it looks like it's about 30 something. I don't know, let's say 33 for now, just as a estimate. It looks like anything above this value where it's not going to be possible for it to go into the region of copper red. So that should be the answer. So it should be around 33. So yeah, let's say 32 would be. So yeah, hopefully you found this video useful. And again, feel free to check out my Facebook page, Barry's Tutoring. And if you'd like to watch more of these free videos, please also click subscribe. Till next time, thanks. Bye.